So let's do another problem together and see how it will all work. Okay, so here it is, how to find the real zeros of a polynomial in step-by-step fashion. So here is our equation or a function. F of x is equal to x cubed plus 6x squared plus 6x minus 4. Okay, so see, a polynomial that is degree 3 or higher, because we already have strategies for degree 1 and 2. All right, so our first step is to find all the possible rational zeros. Okay, so like we just said, that was the plus or minus p over q, right? So in this case, p is all the factors of the negative 4, so that's plus or minus 1, 2, and 4. And q in this case is the leading term, that's the leading coefficient of 1, so it's just plus or minus 1. So all the possible p over q's are just plus or minus 1, 2, and 4. Okay, so we know that these are going to be our, one of these, or maybe 3 of them, are going to be our rational zeros. Okay, so step 2, we're going to graph the polynomial, and that would be using our graphing calculator. You can use the TI-84 like I'm going to show you, or you can go to desmos.com. You can graph it really easily there. Graph the polynomial and find all the rational zeros. Okay, now what we're going to do from step 1, we're going to use step 1, the possible rational zeros, to set the window for x. Okay, that can sometimes help. So, you know, our p's over q's, these are definitely not all real zeros or rational zeros of this function, but at least one of them is, and that's the one we're looking for. And so we know that the rational zeros are between -4 and 4 based on our work on p over q. Okay, so what I did was graph. I went to y equals and typed in my function. And then you can see down here that I do have the graph. And it's a little hard to see, but I think it looks like there's 1, 2, 3 real zeros. And this one doesn't look like it's on a whole number. This one does look like it's at -2, and this one does not look like it's on a whole number. So we actually know that the 2 that are not on whole numbers, because they're not plus or minus 1, 2, or 4, they are not rational zeros, right? But probably this -2 probably is. So what we can do is go to the graph, and we probably, after it graphs, just want to double check that that 0 is here at -2. Okay. Another way we could do that is to go into the table, because at -2 for x, we should see 0 for y. But one way we can do that, because we've done this before in our calculator, is to go to the calculate button, so second trace, and then number 2 is a 0. Okay. So we're going to have to do our left bound, right bound thing again. So this time we need to go to the left of the 0. So that looks like it's like a little bit above the 0, but it's also to the left of it. Notice it's asking for left bound. So I'll hit enter there. And now we have to arrow over to the right until we're past that 0. So we're telling it we want this 0, not over here, this 0, not this 0. We want just this 0 that we think is at -2. Remember that for the guess, you can just hit enter. And yes, this confirms the 0 is at -2, okay? If you look at these other zeros, again, you can tell that they're probably an irrational 0. They are real, but they're not going to be a good number that can be turned into a fraction or a whole number. Okay, so let's make a little sketch of our graph. Oh, I already forgot what it looked like. Oh yeah, there it is. Okay, so it goes like this, and then like this, and then like this, right? And that's lovely. And then this is our rational 0 here at -2. Okay, so that is step 2. And then you might want to note that these two zeros right here, these are irrational zeros because they are not 1, 2, or 4. Okay, so next step. Now we have one of the real zeros. We know it's -2, right? But we're not done with the problem because we need to find those other two zeros. Okay. So step 3 is to use synthetic division. And that's why we've been practicing that lately. So we're good at it. To divide, that says divide, out the factor x minus c. Okay, excuse me. So we have the 0 at x is equal to -2. So the factor that we would be dividing out is x plus 2, right? That's the factor, if it was in factored form, that we already know because we know the 0 is -2. Okay, so to review on the synthetic division, we're going to put the -2 on the shelf. We're going to write the coefficients of all the other terms. There were no missing terms, so that's pretty easy. Okay, and then we're going to make sure that we know that we're multiply, add repeatedly. So first you bring down that 1. Now we're going to multiply -2 times 1, get -2, add down. Multiply -2 times 4 is -8, add down. Multiply -2 times -2 is 4, add down. That is our remainder. Okay, our remainder should be 0. If it's not 0, guess what? We did something wrong because we know that this is a 0 of the polynomial. We saw that from the graph. So we know that the remainder is going to come out 0. Okay, so now we have the remainder 0, and that is good. And so the polynomial that we have left is x squared plus 4x, so minus 2. So we want to write that down because remember we divided the cubic by the factor x plus 2, so the degree goes down 1 degree. All right, so step 4 is factor or solve the remaining quadratic. All right, so we have x squared plus 4x minus 2. Remember, we're trying to find the zeros, so set it equal to 0. Okay, what you'll find is if you've done this correctly so far, we know that this isn't going to be factorable because we saw the other two zeros on the graph and they weren't rational numbers, right? So instead, we're going to need to use the quadratic formula. So I think I need a little more space. These problems can take up almost like a whole page, which is a lot, but it can make you feel really smart when you get one, when you finish it. All right, so let's do x equals, now remember, a is equal to 1 here, b is equal to 4, and c is equal to -2. So let's use that in our quadratic formula. So the opposite of b plus or minus the square root, b squared minus 4ac, all divided by 2a. Okay, Do memorize that quadratic formula because you will need to use it for this type of problem as well as for any quadratics that you have. So -4 plus or minus square root. This is 16, looks like plus 8. So I'm thinking 24 right there over 2. And then we're going to want to simplify if we can. So the square root of 24 looks like 4 times 6 to me. So -4 plus or minus 2 square root 6. What I did to think through that is the square root of 24, right? That's equal to square root of 4 times square root of 6. I picked 4 because the square root of 4 is a perfect square. It's 2, and then we leave the root 6. Okay, so 2 root 6 there, all divided by 2. Since the first term and the second term are both divisible by 2, we can just divide by 2, so we get -2 plus or minus the square root of 6. Okay, so that's our solution there. See if I can't fit it all. Okay, and there's really no need to get the decimal of that because we're trying to find the real zero, so we want the exact number like that. And our final answer then, okay, we're going to be asked for two things. So the zeros, first of all, okay, the zeros are x is equal to -2 and -2 plus root 6 and -2 minus root 6. Okay, so that might be one thing you're asked for, to find the zeros. And you can write it that way, or you can write -2 plus or minus square root 6. The other thing you may be asked for is the factored form of the polynomial, right? The polynomial was given in standard form. So to find the factored form, we're going to use the zeros. So f of x is equal to, it's always x minus the 0. Okay, they call the zeros c, so it's x minus c times x minus c times x minus c. Okay, so that would be, in this case, x minus -2, so in other words, x plus 2 times, and then we're going to keep and use these zeros as well. So that's x minus, and then you can just use parentheses, -2 plus root 6, and x minus, parentheses, -2 minus root 6. This is a fine answer if you're not fond of all these parentheses, right, because you're subtracting each zero. Then you could simplify this. Oops, sorry, I'm a little off the screen, so I'll make it a little smaller so we can see the zeros here. So this would be x, and then this is minus a negative here, so it's plus 2, but then it's still minus root 6. And then the second zero that is a little off the screen is x plus 2, and then it's minus a negative again, so it's plus root 6. And then that would be the factored form. I'll highlight that one since you can see the whole thing, and that's the full solution.